Okie dokie. So yeah, this lesson's not that difficult, especially compared to the last lesson. So let's have a look. Yeah. Right, force. I'm sure this is a word, well, I'm sure it's a word some of you know. Do we know this word, force? Yeah, what would you, it's like another word for force. Yeah, in general English, I'd say power, something else. Force, another word for force is force. Yeah. Yeah. Yeah, it's like power, work, or effort. So that's something that makes it move.
Does this start with an M? How much? Oh, my teacher used to define it. How much of a punch? Something like that.
How much of a punch? Yeah, I like this. Okay. Yes, like this. Okay. Anyways, let's have a look. So, we all have an understanding of the word force. But what exactly is force? Like, precisely what is force? Yeah, I have to. Sorry, I couldn't resist not. Okay, so on to the real definition of force. Force is what changes the motion of an object. That is, force will change either the direction, the speed, or both. Right. So force is the thing that changes the direction or the speed, or both, of an object. In other words, simply put, force is what causes an object to accelerate. So the force is the cause of the acceleration. Force causes acceleration. That's kind of my key understanding of what force is. Yeah, so this is a good definition. If you can write just this much down. Just getting an email in on my iPhone here. Got that written down? Yeah? I'm sure you understand my picture in the last slide. I can see. And I don't know what this is. Yeah, which one though?
Overwatch.
Ah, Overwatch with hang on, let me think. I know some of their names. Hang on, I know at least one of them, I'm sure.
The ninja?
No. Tracer.
Oh yeah.
Yes, okay. That took a lot of effort. That's the only one I know.
Good enough.
Okay, you have this? So, okay, usually force causes an object to accelerate, but not always. Sometimes actually force, now you don't need to write the next part down. Sometimes force has other effects, like changing the temperature or the shape of an object. So for example, if I have like this piece of paper here, okay, I could use a force to accelerate it, but also I could use a force to change the shape, or maybe if I rub it to change the temperature. So not always, but for us, force will change the acceleration, but it can also change the temperature and shape. Anyways, the key point here is it's true to say if an object is accelerating, then a force is being applied. Like, that's the simple fact. If something is accelerating, there must be a force doing it. You cannot have an acceleration and no force. It's not possible. So if something is accelerating, there must be a force doing it. I cannot think of any way you can have an acceleration but not have a force. You must have a force. And also, maybe you should write this part down. Force is a vector. Force is a vector. What you need for the exam really is this, and also that I said force is a vector. That's important. Have you seen this definition before, or something like it? Maybe, who knows? Possibly. Continue? Yeah? Okay. How do we measure force? So the unit we use is measured in newtons, yeah. And we use the letter N. Now, you might remember that this was not one of our basic 7 units we did in the first lesson. You notice that Newton wasn't part of the 7. We had meter, we had second, we had kilogram, we didn't have Newton. So, what precisely is a Newton of force? So how much force is a Newton of force? Does anybody know this definition?
Equals ms, which m is mass.
Yeah?
S is the...
Yeah? Go on.
It's a kilogram per something.
Distance.
No, it's times something.
You're right, it is something. What exactly?
Is it? It's not distance. Is it distance?
There's no distance in it.
No?
Well,
Acceleration.
yes. Acceleration is part of the definition. Okay, see,
Yeah.
you're not sure. Let me show you. A Newton of force is the amount of force required to accelerate 1 kilogram by 1 meter per second squared. So if 1 kilogram has an acceleration of 1 meter per second squared, we say there is a Newton of force applied to that. This definition could be asked in the exam. It's a good definition for the exam because it's not too long. Now, my grammar's bad. What's wrong with my grammar? I have a typo here. I have the wrong tense, yeah. I mean, I did that on purpose. Can you spot the mistake in the definition? It should be a Newton of force is the amount of force required to accelerate, not accelerated. Please don't write the D. Accelerate a kilogram mass by 1 meter per second squared.
I was kind of right.
Yeah, you were close-ish. Okay, you got that definition? Yep. And you could get this in the exam because it's not a big definition, so it's easy to write in the exam. Alright, so learn it off perfectly. The relationship between force and acceleration is given by what's called Newton's second law. We will study the 3 laws, but to begin we'll look at the second law. We'll look at the 3 later. One way to state his second law is simply F equals ma. So when we have a force that causes an acceleration, we can have a relationship between force and acceleration by this formula, F equals ma. So if we know the F and the M, we can know the A. Or likewise, if we know the M and the A, we can know the F. F is the force, M is the mass, and of course A is the acceleration. This is Newton's second law, of course important. You can make sure you definitely have this. Okay. Got that formula? F equals ma. In fact, there's another way to state Newton's second law, and that is something we'll look at later. But now, before continuing, I want you to do a little exercise for me. So I want you to look at the units on the left, look at the units on the right, and let's see what we get. So what units do we have on the left? N, newtons, right? And what units do we have on the right? kg, ms minus 2. So in fact, what we have is another way to state what a newton is. A newton is the same thing as a kilogram meter per second squared. So you could say 10 newtons of force, for example. That's the same thing as, say, 10 kilogram meters per second squared of force. In other words, a newton is the same thing as that. This is part of the basic 7 SI units. So you might remember that I said we can make new units using the basic 7. And here's an excellent example of that. By using the base unit kilogram, meter and second together, we can make this new unit called a newton. So we can always write all our units using the basic 7 units, and this is a good example of that. And this is something you get in the exam sometimes as well. They might ask you, 1 newton show, or 1 newton is the same as what other base units, or something like that. Okay. Continue. Let's see. Right. Here's a very simple one. You can do this in a few seconds. Tell me the force here. A 45 kilogram girl starts to run from rest with an acceleration of 2 meters per second squared. What is the force she is applying to accelerate? 90 what? Newtons. Do I even need to write that down? No. Okay, now here's a real one for you to try. You see a barista. Who's a barista?
At a coffee shop.
Yeah, good.
Oh.
Yeah, what's the barista do?
It's like a bartender for the coffee shop.
Yeah, coffee shop bartender, yeah. Good. So, you see a barista, the coffee is at rest, and the coffee is initially at rest, and you estimate it leaves his hand at 30 centimeters a second, so he hits it, and it moves at 30 centimeters a second, and he seems to touch it for 1 second. And also, you guessed that the mass is about 500 grams. How much force did his hand apply to the cup? So what's the force here? Okay, try that. Oh, come on, if you break your back. Come on, stop. You know what will happen? If you break your back, I'll have so much paperwork to fill out. So much paperwork. It just... There must be like at least 3 forms I have to fill out if a student dies in my class. Okay, if you can try this one, please. I'll give you a minute. This one's not as easy as the last one, but I think you can get it. Oh, and of course, there's also the complication of this. Don't know, could be. I have to work it out. It should be quite small. Did you convert centimeters into... Yeah. You said 0.15 watt unit. Yeah, that's it. You stuck? Or you know what to do?
We timed the acceleration.
Yeah, do you know the acceleration?
36 per second divided by 2.
Yeah, we got the idea, I think, here. So, here's the cup, and he pushes it, and it goes from 0 meters per second up to 0.30 meters per second, and the time to do that is 1 second. So by just using the formula V equals U plus AT, 0.3 equals 0 plus 1a. We get a is 0.3 meters per second squared. And so Newton tells us F should be ma, which is 0.5 times 0.3, which is 0.15 newtons. Yeah, that's okay. Let's have a look at another one now. Back to my car. 1,200 kilogram car is travelling at 100 kilometers per hour on a motorway. The driver suddenly brakes and the car screeches to a halt in 100 meters. How much force? Now, of course, there's a grammar mistake again. How much force are the brakes applying in order to bring the car to rest? In other words, what's the force by the brakes? No, wait, before you started, this is good English practice. What's my grammar mistake here?
Great.
Very good, yeah. I spelled it the wrong way. I should have spelled it what way?
B-R-A.
Yeah, the way I spelled it is which brake? Yes, that's it, yeah. Do you know this? There's two spellings of brake. Brake, the way I spelled it is wrong because that brake means like this. Brake with an A is the brake when you stop the car with your foot. Okay, so you can fix that. Not that it changes the physics. The car moves along and then suddenly stops, and I want to know how much force was required to stop it. Do you understand? Yeah. Now, you notice how I said the force is negative. It's negative because it's decelerating. The car is moving this way and the force goes that way. Yeah, to stop it. Okay, I'll give you a minute. Try and calculate the force. Before you do, are you expecting a big or a small number? It should be a pretty big number. Yeah, okay, try.
So the acceleration is negative, and so the force will be
Negative, yeah. The negative is the direction of the force because of the vector indicating reverse, backwards. You got an answer for force? Yeah, is it pretty big?
4,600.
That's pretty big. It's pretty big. You got an answer? No?
I got it.
What'd you get?
3,333. It's not deal.
Well, no, you got 3,000. You got 4,000. Let's see. Let's see who's right. Maybe both of you are wrong. Let's see. I know both of you can't be right. That would be not possible. You have, what answer did you have? A third answer.
Wait, the distance of 100.
Yes.
166.
Okay, we have a third answer. Great. Any good answers? Over here? Any answer?
4,680.
That's what you got.
Well, this is
1,680.
4,629.
Yeah, okay, yeah. Let's have a look. Okay, so, what's the U here? Let's see. Whatever 100,000 over 3,600 is. That's fine. The V? 0. The A we don't know, the T we don't know, the S is 100. And we really want to know the A. So what gives us the A? What formula would be best?
A equals
It's going to be the v squared one, is it? Yeah, v squared equals u squared plus 2as. So the a would be v squared minus u squared over 2s. Okay, so the a is 0 squared minus 1, 2, 1, 2. Okay, that's 1 over 250 over 9 is the simplest, is it? Thank you. Squared over 200. Yeah? That's for the a. But I want the f. What does f equal? F equals ma. So f here would equal m times this number, which I said was 1200. Alright, let's see what we got here.
Yeah,
Yeah?
1200 kilograms. Should we convert that?
To what?
Because it's kg per meter.
Yeah. Divided by 200. Okay, good. 4629. So 4630. I would say. With a minus. Or, if you want, minus 4.63 kilonewtons. Okay. Good. So what went wrong for you? Your answer was kind of close, but off a little bit.
I changed kilograms to grams.
Ah, interesting.
Some wrong stuff.
Yes.
In the group.
But this is okay now?
Yeah.
Yep.
Why is kilonewtons?
You don't have to. I like to use my prefixes. Because this is 4,000, so 1,000 is a kilo.
Oh.
So that's all. Yeah. Okay, is there more to this one? No. That's a large force. So the brakes in the car, they apply a large force to the motion to stop it. It's very significant. Okay, so let's have a look. I think this lesson is probably easier than the last one. What are the questions like for this? How many did I give you? Yeah. Okay. How are we doing? Right, we've got 10 minutes left. So if you can use these last 10 minutes, you have a choice. You can either continue with the last worksheet from the first class, or you can try some of the force questions now. You can do these for 10 minutes.